Okay, so I'm very glad here to receive this award for the contribution on mining, fusion, and anonymization of big data. So as we know that this big data consists of these 5 V's, right? So if I look back on the history of the type of work I'm doing on data mining, right? So we started around 1994 to looking at scalable frequent pattern mining with Ming-San Chen. And our first paper appeared around 1995 in the Sigmore conference. And then subsequently, we look at this subspace pattern, subspace-based clustering with Charu. And then we also look at this pattern-based clustering with Wei Wan, right? She's the service award winner this year. And then with Bing Liu, we have looked at text mining and PO learning. By 2000, then we started to look at data stream mining. So with Charu, Jiawei Han, we started to looking and with Jianyong Wang, we're looking at this data stream clustering. And then with Fan Wei and this Haixun Wang, we're looking at data stream-based classification. And then we started to look at graph mining with this Xifeng Yan and Jiawei Han. And then we're also looking at, starting to look at privacy-preserving data publishing. By 2007, we started to looking at the veracity issue, like stamp detection, entity disambiguation. And then by 2008, around that time, we're looking at this heterogeneous information network, this with Yi Zhou and Jiawei Han. And then we also started looking at this multi-source of fusion. Now, this included the multi-view and multi-modality type of learning. And then we're also looking at various applications like social network mining and brain informatics. So I'd like to thank all my collaborators. I have more than 600 collaborators, so I can only list the major one. And I also like to thank NSF, since I moved to UIC, give us various funding support. So today my talk will be focused on the fusion aspect. We're looking at how do we mining heterogeneous data sources. Okay, so as we know that in the era of big data, we have all kinds of data, right? So the important thing is that how can we fuse multiple data sources together to get a better understanding of the subject we are trying to understand. And if you look at some of the commercial companies, for example, like Google, they have many different touch points. They can get information about their user. For example, from the Google search, they can get a search log. From the Gmail, they can get the keyword in the email. And then from the Google Maps, they can get the location of their customer. And then from Google Plus, they can also get their friends, right? And then there are other examples. For example, for this, if you want to detect terrorist plot, there you can see that the government agency trying to get information from various sources, from the social network, from the cell phone log, from the transaction log, all those kind of things. So if we're looking at, for example, like a drug discovery, right? So a chemical compound can be represented as a graph, and then basically we want to predict whether this chemical compound, for example, can cure disease or not. So one of the things which we do with this Xifeng Yan and Jiawei Han is that we're looking at how do we predict whether a particular graph with certain label or not. And then what we find out is that we can use the subgraph structure as feature to do the prediction. So the challenge is really on how to identify this discriminated subgraph feature. Okay? But subgraph feature is only one type of information. There are many types of information which is available. And the question is that how do we connect it to the chemical compound? For example, we have information on gene ontology. We have information on whether a gene is related to a particular pathway. And we also have information on whether a chemical compound will be able to bind to a gene, right? So if we can connect all those information, then we'll be able to get a much deeper understanding and better prediction on what a chemical compound will be useful to cure a particular disease. So we can represent this as basically as a network. This is what we call a heterogeneous information network. Actually, this particular network usually integrates 42 different heterogeneous public database, like PubChem, and some of them is from chemical, some of them is from drug industry. All right. So basically, with this particular type of graphical representation, now we can see that two chemical compounds, right? Whether they can be considered to be similar, it can be because they have similar side effect, or because the gene they bind to, they relate to the same pathway, or because of the gene they relate to interact with each other. So we can use this kind of relationship to help us do the prediction. So basically, this we can see that from the previous graph that the two chemical compounds, there are different metapaths can connect them, and each of them has a different semantics, right? So the important thing is that which metapath is more important, and then how do we weight the different metapaths? So in the paper with Yizhou Shen and Jiawei Han, we are looking at the general issue on how to decide the importance of metapaths and how to weight them, right? And then, for example, we want to do a classification here, is that right? So before, in a homogeneous network, you just look at your neighbor's label and then use that to help you do the prediction. But in this heterogeneous information network, then you look at your generalized neighbor based on the metapath, and then look at their label to do the prediction. So for example, in here, we're trying to do a drug prediction, because this is a multi-label issue. So we measure that through various measures like micro F1 Hamming loss or subset 0-1 loss. But you can see that in the red box, which we use this different type of metapaths where we try to integrate the information together, we'll get better accuracy. Consider with the yellow box, which only use the internal structure, right? And there are many other applications we can look at. For example, if we want to look at in the social network, how do we do friendship prediction? Certainly, social network is not unique, not just Facebook, right? There are many different types of social network. So each of them, each of the person may participate in multiple social networks, right? So each social network, you can view it as capture a particular aspect of a particular person. So if we can collect information from more than one social network, that will be able to help us have a better understanding. So the question is that how do we, if this fuse two different social networks together? The first issue certainly is that a person, when they participate in multiple social networks, those social networks, in that they may have different identity, okay? So the first issue is that how do we resolve this, this identity issue, so we can know that the two persons with two different identities are really the same person. The other thing is that once we make the connection is that what kind of knowledge can we transfer between the social network? In a social network, certainly there are many information there, right? First of all, we have the social link exists, and then you also have location information. So if a person tweets, you also get some content of his interest, and then you also know the temporal activity. What time does the person make the tweet? So basically, in a social network, we get these four types of information: the who, what, when, where, right? So even in a single social network, if you want to use this kind of information to predict social link, that is how do we do friends recommendation. Okay, is a challenge, right? So if we want to use multiple social networks to help us to do the prediction, okay, then the first thing is that we want to connect the two social networks, right? So that's we know that which two persons are really the same across the social network. So this is called the anchor links, right? So the person connected together, we call the anchor user, right? But most of the people are not really connected to the other network. So this is referred to as a non-anchored user. And basically, we are trying to use this partially aligned social network to do the prediction. In some social network, for example, in these 4 squares, right, you can specify the Twitter account. So for the people specifying the Twitter account, then we know the connections, right? So basically, we will have some anchor link connection, so that we can use as the training data to help us predict more anchor link. And then with this anchor link predictions, right, then we can improve the social link prediction in each of the network, and then we can use this iteratively to do better anchor link prediction. So in here, now we want to do this social link predictions, right? So the question is that how do we do the social link prediction? Basically, the link prediction, you can view it as a binary classification problem because we are trying to predict that whether the link exists or not. Exists is 1, not existing is 0. Right? So the question is that then, and if we treat it as a classification problem, then what are the features should we use? Okay? So basically, we can use this this concept of this heterogeneous information networks, right? So for each user, if we represent it as a schema, that you can connect to some users, right? Or he can write some posting, and then the posting have a location, also contain some words and timestamp. Okay, so 2 users, for example, U1 and U2, they can be related because they have the same follower, or they follow the same person, or they post the same word, or their posting occur in the same location or at the same time. So you can see there are different ways we can connect these 2 different users, and then some of the paths may be more important than the other. Okay, so how does the internetwork come into the picture? Because in here, for example, if we want to see whether A and B are related in the intranetwork relationship, right, A and B are not connected in any way. But if we look at the other networks, right, then actually we may find a path to connect A and B, because what happens is that in the other network, A and B are actually friends. Okay, so another example, for example, C and D. Again, C and D in this network is not connected. But if we use the other networks, right, then they are connected. You can see that because C connects to A, but A in the other network connect to D. Right? So then we can find a path back to it. Right? Okay. So again, you can see that this is the same for A and E. Okay. So using the other network, we'll be able to find a path of connection. Certainly, this is a simplified diagram. We're only looking at homogeneous networks. Right? But if the network is heterogeneous, then a person is not necessarily directly connected to the other person, but through certain meta paths. For example, they are posting the same word or occurring in the same location. Okay? So again, we can do this meta path, do this anchor link prediction through this meta path relation, because 2 persons in different networks, they may be related if they are all linked at the same person, or if they are in link at the same person, means that their neighbor are actually the same person, or they are posting in the 2 different networks, 2 persons posting the same type of word or things like that. Okay, so again, so if we use this kind of relationships, then we'll be able to do a more accurate prediction that compare with, for example, you're doing the independent prediction, or you do not consider the meta-path relationship. Okay, so we can also apply this to recommendation. For example, we know that recommendation, certainly the most common way is to use collaborative filtering based on the rating you have on the movie. Right? But there are many other types of information. For example, user attribute. For example, which group the user is joining, or the user has a social connection. Right? That also is useful information. If you like the movies, right? The movie also has different attributes. Right? What type of movie it is? It can be an action movie. It can be a romance movie, or the actor and actress can be relevant. Right? So basically, if we want to do a rating predictions, right? So user rating is one source of information, but the object attribute means the movie attribute is the information. User profile attribute is another source of information, and user social relationship is also a different type of relation. So if we fuse all this information together, then we'll be able to do a better prediction. Then again, we can use this heterogeneous information network to represent this, because you see, user can connect to a user because they are friends, right? Or they can join in different groups, right? And then they also rate different movies. Right? Yeah. But certainly, this is a little bit more complicated than we mentioned in the beginning, because in here, compared with before when we are talking about this drug discoveries, right? At that time, we only consider the link connection. But in here, the link also has an attribute because there's a rating associated with it. So you really have to have the similar type of rating in order to consider the two persons to be similar. The second thing is that when we talk about this weighting on the metapath, before we are talking about it's a global weighting. But in here, actually the weighting need to be individualized because the information we have from each user is vastly different. In some users, they have a lot of friends. Okay? So you can use the friends rating preference to help you do the prediction. And in some cases, the user have very few friends, but he do a lot of rating. Then you can use the rating information. So really, which metapath is more important in here has to be individualized. And also we need to take the weight into consideration. So we consider, for example, in here, if two persons, they all rated the movie to be 1, then they are similar. Or they gave the rating, in one is I, the other is J, but the two rating I equal to J, then also is fine. Right? So again, this is a different metapath we can consider for the two users. For example, the two users in the same group, or they give the movie the same rating, or the movie they give the same ratings under the same director or the same actor. Right? So if we look at it, then we can see that by consider this, the multi-type of information, fusing them together, we'll get a much better prediction than traditional collaborative filtering, only consider the rating information. And then we can also connect to different type of a website together. For example, if you look at an e-commerce sites, for example, like Amazon.com, you only have rating information. You do not really have friends information there. But if you go to a review site, then maybe you will find people which have social relationships. So again, there is a cross-network connection. Right? If we can align some of the entity across the two networks, then we'll be able to transfer information from one network to the other. So for example, in here, on the left-hand side, right, we have this this e-commerce site. You only have customer, product, and then you have a star rating on those products. And then the other side is a review site where users have rating, right? They also have some write-up on particular item. So if we can line up some of this customer across the two sites and the product and the item across the two sites, then we'll be able to do cross-network transfers, right? For example, in here, for example, we can connect a customer through the user in the other network, so we can connect two customers together, either because the customer connect to a user has another friend connect back to another customer, so you can connect them. Right? So there are various ways you can connect them together. So with this type of information, then we'll be able to do a more accurate prediction compared with the traditional approach. Okay, so finally we're looking at medical applications, right? So for example, now we consider, we are very concerned about whether the brain is functioning correctly or not, right? Because as people age, they can have this Alzheimer's disease, right? For example, if we take an fMRI over the brains, right? Here we have two photos, right? One is a normal person, the other is an abnormal person. The question is that how do we decide that? So one way is that we can map the brain into a network. Okay? So two nodes represent two different brain regions. And then from the fMRI, we get a time sequence on the brain activity. So if the time series are correlated, then we consider the two brain regions to be connected. Okay? So in that sense, we can get a graph or network out of a brain. Okay, but this certainly is a more complicated graph because the edge is not certain. Actually, edge is a probability. So at the very beginning, when we talk about this drug discovery, right, we talk about mining in this discriminant subgraph over a certain graph. But this is uncertain graph, so it's a bit more challenging, right? But again, that if we're only using this fMRI image, we still have limited information, right? But actually, for particular patients, right, we actually have a lot more information on the patients, right? So we not only having this image, we also have some cognitive measure, we have blood measures, right? We have all this kind of measures. So if we can fuse them together, then we'll be able to do a better job, right? So one way is that, for example, we can use, based on the image or the network, we can use the deep learning to learn this latent feature, but we also can use other side view information. That means that the other medical tests, or we consider them as side view, and use them to guide the latent feature learning. For example, if the side view is to be very close, right, then we are forced the latent feature also to be close. Okay, so in that sense, then we will be able to do a better prediction. So you can see that this is with the side views, right? If you do not consider side view, just do deep learning, then the accuracy is less. Okay, so in summary of my talk, that as we know that the data is becoming increasingly important as recognized as a valuable asset. So exploring big data will offer new opportunity to disrupt existing business model to create new ones. And certainly, to explore big data, there are many challenges, right? We know that there's the 4V challenge, and today we are more focused on this variety issue, that how do we fuse those heterogeneous data sources together so we can get a deeper understanding of the problem. So big data will have a profound impact on future business, education, everyday life. Okay, this is the end of my talk. Thank you very much.
Right. I would like to thank Philip for the talk. It was a really great talk. Have any questions? We have time for one or two, I guess.
Since we don't have other questions from the audience, I thought it was a really interesting talk. So what are your opinions on the major directions and challenges that we need to still solve in the next several years as big data evolves and we need to address newer communities?
Okay, so I think as we know that the data is a valuable asset, a lot of companies trying to acquire other companies just to get the data, right? But the issue is that all those data are gathered very differently, right? So when you want to merge different data together, right, fuse the information together, it is a big challenge. Because that really decides the value of the data, right? We cannot fuse them together. And then on top of that, there are also is this veracity issue, because different data sources are collected differently, so they have different level of noise or reliability in there. So that is another factor you need to put into consideration.
All right. I'd like to thank Philip once more. Thank you so much for the talk, Philip. Appreciate that. All right, just a quick reminder, we will see you tomorrow here again. We start at 8 o'clock in the morning. And our poster sessions are running as we speak right now, so I'll encourage you to attend those poster sessions as well. Try to do one-on-one discussions with the authors. And I think with that, I'll declare this opening ceremony closed. Thank you so much for joining us today.